we can make the altitudes of a triangle in Geometry Sketchpad as well. So if I make a triangle, label the vertices, I want to make a perpendicular from A to side BC. If I highlight A and segment BC and I construct the perpendicular line, you can see that that line will be in the exterior. It doesn't intersect BC. This shows that the altitude of a triangle can be in the exterior of the triangle. So if I take side BC and I construct, I have to unhighlight the perpendicular, and I want to construct a line. Now I can show that the altitude is in the exterior of the triangle. I also can make this line into a segment by highlighting the perpendicular line, getting a point, and bringing it down and moving the point until both lines change colors. And then I know that would be the position of that point. And now I can label that. And AD is the altitude of BC. Also, I can make AD into a segment. And I'm going to highlight the line. I have to be up here away from the segment. And I'm going to highlight the line. I'm going to right click and I'm going to hide the perpendicular line. And what I have left is this altitude. So AD is the altitude for triangle ABC, and it's in the exterior of the triangle. Now if I want to find the altitude for AC to vertex B, I highlight B, I highlight AC, and I construct a perpendicular line. Now this time the perpendicular line is in the interior. And I can do the same in that by highlighting AC, I can get a point and position the point at the intersection, right click and show label, and I want E to be in the exterior, so I move it. If I want BE to be a segment, I can construct the segment. If I want to get rid of the line, I'm going to unhighlight the segment and come up to highlight the line and right click and hide perpendicular lines. So I have the altitude BE in the interior of the triangle. This one in the exterior. The third altitude would be from AB to E. So I'm going to highlight AB and point E, or C rather, AB to point C. Need to highlight the segment AB and the point C. And I want to construct a perpendicular line. And again, the altitude is in the exterior. So if I make AB a line, to unhighlight the perpendicular, make AB a line. Then I see the intersection and it is perpendicular. Now I'm going to go back and I'm going to make AD a line, and I'm going to make EB a line, EB as a line, because I want you to see that they do intersect at a point, and that point of concurrency is the orthocenter. So I'm going to choose the point. I'm going to come down until I have two of the lines highlighted, and then position that point, and then I can name it point F, and that is the circumcenter. But unless you make the lines, then these are not going to intersect. If I just have segment BE, and I didn't give this little fella a name, so I'm going to bring G down. So CG is the altitude with the base of AB and vertex C. Then BE is the altitude with base AC and vertex B. And then AD is the altitude for BC and vertex A. The altitude can be in the exterior, and the orthocenter is where they intersect. Now, if I take A and I drag it, notice what happens to the point of concurrency of the altitudes. As I change it from an obtuse triangle to a right triangle, notice that the orthocenter is at the right angle. And as I drag A again, notice that the orthocenter is in the interior. So the orthocenter of an acute triangle is in the interior, and the orthocenter of a right triangle is at the vertex of the right angle. And then of an obtuse triangle, the orthocenter is in the exterior of the triangle.